quadrilateral ABCD has perpendicular diagonals that meet at E. The circumcircles of ABE and CDE have centers that are 4 units apart and intersect again at point F, where angle ABF equals 30. What is the area of ABCD? Quadrilateral ABCD here, which has perpendicular diagonals that meet at E. And then we also have the circumcircles of triangles ABE and CDE, which have centers 4 units apart, and they intersect at E, and again at a second point F, here. It's given that angle ABF, this angle is equal to 30. And based on this, we have to find the area. So right away, we notice that we have 2 cyclic quadrilaterals, ABEF and CEFD. So we have to do some angle chasing. Let's do that using the cyclic quadrilaterals and the diagonals of ABCD. We have angle ABF, which is given to be equal to 30, is equal to angle AEF. So I can label this angle here also as 30. Now angle AEF, that's equal to pi minus the angle on the other side of EF along diagonal AC, which is angle CEF. So pi minus angle CEF. And because quadrilateral CEFD is cyclic, that's precisely equal to angle CDF. And now we know that the diagonals of ABCD are perpendicular. So angle AEB must be equal to 90, which is also equal to angle AFB. So since angle AFB is a right angle and angle ABF equals 30, we know that angle BAF, this one over here, that must be equal to 60. We can do more angle chasing. Angle BAF from cyclic quadrilateral ABEF, that's equal to pi minus angle BEF, which using the other side of EF on diagonal BD is just equal to angle DEF, which is simply angle DCF. So angle CDF is equal to 30. Let's do it in a different color. Angle CDF is 30, and angle DCF is 60. And obviously angle DFC is 90 because that's angle DEC, which is obviously 90 because the diagonals are perpendicular. So we found another 30, 60, 90 triangle in triangle FCD. So now we know that triangle FAB is spirally similar to triangle FCD. We conclude that there exists a spiral similarity centered at F that maps segment AB onto segment CD. Now looking back at the problem statement, it tells us the circumcircles of triangles ABE and CDE have centers that are 4 units apart. But the centers of these circles are just the midpoints of AB and CD because they're right triangles. And the circumcenter of any right triangle is just the midpoint of its hypotenuse. So circumcenter of triangle EAB, which is the circumcenter of triangle FAB, is the midpoint of AB. Let's call that M. And the circumcenter of triangle ECD or FCD is the midpoint of CD, which is N. And the problem is just saying now that MN is equal to 4. Now, because of the spiral similarity that maps segment AB onto segment CD centered at F, it would also map the midpoint of AB to the midpoint of CD. So M is mapped to N under this spiral similarity, A is mapped to C, and B is mapped to D. So we can say that triangle FAC is spirally similar to triangle FMN, which is spirally similar to triangle FBD. Because of this spiral similarity that maps A to C, M to N, and B to D. Now to finish, we want the area of quadrilateral ABCD, and because the diagonals are perpendicular, this is an orthodiagonal quadrilateral, we can just do AC times BD over 2. So we need AC and we need BD in order to find AC times BD over 2. Now, using this spiral similarity, we can get some lengths in terms of the length MN and other lengths that we know. So let's try to find AC. First, we know that FA over AC equals Fm over Mn, which is 4. So what is AC here? Well, we know that AC times Fm equals 4 times Fa. So AC is just 4 times Fa over Fm. And similarly, from this other pair of triangles that are spirally similar, we get FB over BD is also equal to Fm over 4. So BD times Fm equals 4 times FB. And so BD equals 4 times FB over Fm. And now we want the area of quadrilateral ABCD, which is the product of AC and BD divided by 2. So AC times BD itself would be equal to 16 FA times FB over Fm squared. And so the area of quadrilateral ABCD is this divided by 2, or 8 FA times FB over Fm squared. Now, all we need to do is use ratios in this 30, 60, 90 triangle, AFB, with circumcenter M. So we know Fm is here. And now let's zoom in on this triangle, AFB, with circumcenter M. You know that this angle is 60 degrees here, and because AM and FM are equal, they're both radii, this triangle must be an equilateral triangle with all 3 angles equal to 60. So if the radius is denoted as r, then all 3 of these are equal to r. And even this is equal to r. Now, what's the fourth side? Well, that's just FB, which is root 3 times r, by common properties of the 30, 60, 90 triangle. So what do we want? We want 8 FA times FB over Fm squared, which is just 8 times r times root 3r over r squared. The r squareds cancel out, and we get 8 root 3, which is equal to answer choice E. Thank you for watching my YouTube video, and please follow my channel.